The position in meters of a particle moving on a straight line is given by s of t equals 2t cubed minus 9t squared plus 12t minus 4 when time is in seconds. When is the speed increasing? You have to be really careful about remembering what this asks for. Speed is increasing is not the same as velocity is increasing. Speed is increasing when velocity and acceleration have the same sign. Because what's happening is that a positive velocity means that a person is traveling to the right, and a positive acceleration means that they're being pushed, there's a force pushing them to the right. So if they have the same sign, if they're both traveling to the right and being pushed to the right, they're going to start going faster and faster and faster. Their speed is going to increase. Same thing, if they're being pushed to the left, acceleration is negative, and going to the left, velocity is negative, then they're going to be going faster and faster and faster in that direction. But if velocity and acceleration have opposite signs, so if someone is traveling to the right but is being pushed to the left, then they're going to slow down. Going the other way, traveling to the left, being pushed to the right, they're going to slow down. So what we're going to do is we're going to find the positive negative line for velocity, the positive negative line for acceleration. We're going to compare the two. So if we think about our little charts, here's velocity, here's acceleration. We're going to be finding these two and comparing them. But we really don't need the charts in terms of the translations and all, because positive and negative we can find directly from the equation. Okay, so let's start with what we have. We currently have position s of t equals 2t cubed minus 9t squared plus 12t minus 4. And we know that that's position over here. So if we take the derivative of that, we'll get velocity. And we need velocity, so let's pull that out over here. And this will go right up here. We actually did this in the last lesson. And if we keep taking the derivative, then we'll get acceleration, which we also need. Again, this was the same thing that we were doing before. Let's see, it was negative and then positive. Now what we're going to do is we need to compare the two. So let's take acceleration. And compare it to velocity. Well, let's see. Oops. It does help with these things if I mark my acceleration correctly. This was first negative and then positive. So we're looking for where they're both the same sign. So here, positive and negative. That's not it. Here, negative and negative. Yes, this is good. So from 1 to 1.5, negative and positive, we don't want that. Here, positive and positive. So that means speed is increasing when t is between 1 and 1.5, or when t is greater than 2 seconds, because velocity and acceleration have the same sign. Notice this is an entirely separate question from if we were asked when is velocity increasing. This is just read off the table. So in this particular case, we've got velocity. We're looking for the increasing, decreasing line. That corresponds to acceleration being positive, negative. We found this already. Velocity is increasing. We just read that off the chart when t is greater than 1.5. Asking about velocity versus asking about speed are two very different things. We can also answer the same types of questions if we're given a graph. So here we're told the velocity of a particle is graphed at right. We want to know when the speed is decreasing. So speed is decreasing. That means velocity and acceleration have opposite signs. We're only interested in velocity and acceleration. So we're going to want acceleration and velocity. Now, since this is a graph, we're going to be doing our translation tables from what we know of velocity. So increasing, decreasing for velocity is going to translate into positive and negative for acceleration. So let's start there. It's increasing until 2, then decreasing down to 7, then increasing again after 8. Positive and negative, positive until 4. Negative until 8, and then positive again afterward. So if we translate this velocity over to acceleration, positive, negative, positive. So to solve, we need to compare acceleration and velocity. So here's acceleration. Here's velocity. And we are looking for opposite signs. So these are the same sign. Now this is negative and this is positive, right between 2 and 4. Negative and negative. Here's a little negative and positive in between 7 and 8. So therefore, speed is decreasing when t is between 2 and 4 or 7 and 8 seconds. Because acceleration and velocity have opposite sides.